right, so in this lesson, we're going to be talking about piecewise defined functions. So here in example 1, Alani has a summer job as a lifeguard. She makes $12 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly pay, or $18 an hour, for each hour over 40 hours. We're supposed to make a graph, which I actually have already done. Write a function that shows Alani's weekly earnings based on the number of hours she works. All right, so first things first, we know that we have 0 to 40 hours. 0 to 40 hours, she's going to be making $12 an hour. So if I wrote an equation for that, that would be y equals 12x. All right, now then she has another section where she works more than 40. All right, so more than 40 hours. And if I thought about the equation for that, that would be 18 times the hours that she worked. However, you don't get the $18 for every hour, just the ones above 40. So to show that, we're going to take the number of hours and subtract the first 40, I guess is a way you could think of that. So hours minus 40. So if I distributed that 18, that would give me 18x minus 240. So I have two different equations, and those correspond to two different graphs, two different pieces on the graph that I have over here on to the right. So I know that my x-axis is the hours that I have worked, and the y-axis is the pay that I'm going to receive. So this first part in the red, that part right there represents the first part of my equation, the 12 times x. The green part, that represents my second equation. So to write this, I have f of x, because that represents my y, equals. Now I'm going to leave a little bit of space here because I'm going to put two equations here. All right, the first one is 12x. And then the second one is my 18x minus 240. And then we're going to put a little brace thing. That way we can say y is equal to this and y is equal to that. All right, now we have to have stipulations. So we're going to put a comma. So the stipulations are, if I work 0 hours to 40 hours, I get paid 12 times x. So my x is between 0 and 40. Now I have to decide if I should put an equal to bar underneath these inequality symbols, and I do need one. I can work 0 hours, so that's an hour amount that is included, and this goes all the way up to 40 hours, a full work week, so this is equal to. All right, the second one is anything that is above the 40 hours, so any hour greater than 40 hours. Now, let's say that I didn't have my graph made yet. I would make maybe a table of values. So let's say I started with 20, and we're just going to go up by 5 and make a table and try to graph this. Now, I could start at 0. That would be fine as well. Let's just go up to 55. So if I wanted to know what I would get paid if I worked 20 hours, I'm going to take that 20 and decide which piece it fits in. Well, 20 is between 0 and 40. So since it's between 0 and 40, I will use the 12x as the equation I plug into. So I take 12 times 20, and that's going to give me 240. So I'm going to go down here and decide which piece this fits into. So an x value of 25. That is also between 0 and 40, so I plug 25 into the 12x. 25 times 12 is 300. So I keep going down. 30 also fits into that same piece, so I plug that in and get 360. 35 also fits in that piece, that's 420. 40, I have to think about this because 40 is listed on both of these pieces. I see that this is less than or equal to 40, and this is greater than. Since the equal to is on the top equation, I will use the top equation. So I plug 40 times 12 is 480. And then I get to 45, but 45 is greater than 40. So now, Since 45 is greater than 40, I need to use this equation. So I do 18 times 45 minus 240. That gets me 570. And then 50 and 55 also fit into that piece. So I plug those in. And now I have some numbers to graph. So if I didn't have a graph, I would plot these points. So if I go to 20 up to 240, 30 up, or 25 up to 300, 30 up to 360, 40 up to 480. All right, so on and so forth. I would graph all those points and I would end up with this graph. Now I do want to point out that right here on my graph, these 2 points at 40 overlap. All right, notice that that is a red circle. That means that the filled in portion is the one that is in the red graph, and then the green graph is the one that's not included in. All right, so I have already written over here what we just had on the previous problem. All right, it wants to know how much she's going to earn if she works 37 hours. So I have to decide, is 37 going to be between 0 and 40, or is it bigger than 40? It is definitely in between 0 and 40, so I will plug into the 12x, so 12 times 37. That's going to get me 444. All right, and then we have part B, which is 43 hours. 43 is bigger than 40, so I will be plugging into the 18x minus 240. So I have 18 times 43 minus 240, and that gets me 534. All right, now we're going to practice kind of graphing 3 different pieces on one graph. So I have 3 sections. Now it is really important that you can look at an equation and tell what kind of shape it is. All right. If you looked at some parent functions, you would see that if it has a power of 1, the x, then that means it's going to be linear or a line, okay, just straight line. If you see that the x has a power of 2, that's going to be a parabola, a quadratic. That'll be a U shape of some sort. And then if you look at this third piece down here, again, we have power to 1, so this is also a line or linear. So I'm going to have a line on the left, a line on the right, and some sort of like U shape in the center. So I'm going to do 3 tables of value. I'm going to start with this first piece right here. And I'm going to make a table that goes along with this piece. Now, if you look, we are supposed to be graphing x values that go from -10 all the way to -2. So this graph is going to be a line that goes from -10 to -2. So I'm going to list -10, and then I'm going to count all the way up to -2. But since it's a line, I'm going to skip and count by 2. So let's do -8, -6, -4, and -2. Now, when I graph the point that has an x value of -10, I have to look at this inequality symbol to see if that should be an included value. So I have equal to, so that is included, which means when I graph that point, it should be a closed point. But if you look right here, underneath this inequality symbol, there is no equal to bar, so therefore -2 is not included. So when I graph -2, it needs to be an open point. Now you can get your y values one of 2 ways. Okay, first way is you can take and plug into that equation and do 4 times -10 plus 11 and fill in your table. You can also grab your graphing calculator, go to the y equals, put in your equation. So I have 4x plus 11. Now I want to put in my own numbers because I chose those for my table. So I'm going to go to the table setup menu, which is second and window. And mine is already on ask right there. So I want my table to ask me for x values. So now I'm going to go second graph. That way I'm in my table. If I just press graph, I'm going to be on the graph. If I press second graph, that puts me in the table. Now I already have some numbers here, so I can just type over those. I'm going to put in -10, -8, -6, -4, -2. And there are all my y values. That's what I would get if I actually took those numbers and plugged them in for x in that equation. So I'm just working smarter, not harder. So I'm going to fill in my table with those numbers. So we have -29, -21, -13, -5, and 3. Okay, now I'm going to do the second piece. The second piece is x squared minus 1. We're going to make a table. This time my x's go from -2 all the way to +2. Now, I don't suggest skipping numbers when it's a U shape. If it's a line, you can skip every couple of numbers when you put it in. So we're going to go -2, -1, 0, 1, 2. We're just going to go all the way from -2 to 2. And again, I can either plug into this equation right here and do like -2 squared minus 1, and I could go through and do all of that, or I could use my calculator. So I have 3, 0, -1, 0, and 3. Now I have to think about those endpoints because this end has the equal to bar, so at -2 it's included, so I will have a closed circle. And when I graph x value of 2, that point will also be a closed circle. All right, and then my third graph, which is the 2x minus 10. This one's going from 2 all the way to 10. And this one is also a line, so I'm going to count by 2's. 2, 4, 6, 8, all the way to 10. Now, if I plug in these x values, that's going to give me -6, -2, 2, 6, and 10. And I have to think about the ends. 2, not included because there's not an equal to bar. 10, also not included, there's not an equal to bar. So both of these endpoints should be open circles. Now I'm just going to graph these. So I've got the point -10, -29, and always pay attention to what you're counting by. Like this, my y-axis here is counting by 2's, but my x is counting by 1's, so you have to be really careful. -8, -21. Now the points in the middle, it doesn't matter if they're open or closed because they're not your end points, okay? They're obviously included in that range. So we have -6, -13, -4, -5, and then we should have an open circle at -2, 3. So make sure that it is open, and then you can connect right there. Now we're going to go on to the second one. So I have a closed circle at -2, 3. Now it's overlapping here, so I'm just going to kind of draw it inside of my circle there. All right, closed, and then we have -1, 0, 0, -1, 1, 0, and another closed circle at 2, 3. So this is a curve. We already knew that was going to be a curve. So we draw that in. And then we go to our third piece. We have an open circle at 2, -6. So open circle. And then we have points at 4, -2, 6, +2, 8, 6, and then an open circle at 10, 10. And then we're going to connect those. And we have that line. So there's our piecewise function. Now it's asking us to state the domain and range. So let's talk about the domain. If you're looking at your stipulations over here, the domain, this is your domain over here in this section. If you look at that, my lowest x value is negative 10. And if I follow this up, that goes from negative 10 to negative 2. Negative 2 is not included here, but it immediately picks up at negative 2 on the next piece, and that one is included. Then it goes all the way to 2. 2 is included here. And then it picks back up at 2, not included, and goes all the way to 10. There are no gaps. This goes all the way from negative 10 to 10, and everything in the middle is included somewhere. So I know that I'm going from negative 10 all the way to positive 10. Now, the negative 10 is included, but if you look right here with your positive 10, there's no equal to, so you need a parenthesis. So that means that your x values, this one's included on the left, not included on the right, go from negative 10 all the way to positive 10. And I actually have that as well, like in my tables, you can see it. All right, so let's talk range. Now, I don't have any gaps at all in my domain. So if you look at your range, we already actually have all the y's listed. It starts at negative 29. That's the lowest number I have. So if you look at all of your y values, okay, that's the lowest, still the lowest, still the lowest number that I have. So I'm going to say that I start at negative 29, and at that point, it is a closed circle. So negative 29 is included. All right. Then I go down through and I look for the highest. So 3 is the highest here. 3 is still the highest. Oop, 10 is the highest y value that I have. At that point, 10 has an open circle. So I'm going to say 10 with a parenthesis. So my y values are going from negative 29 all the way to 10. If you look at this visually, I go from negative 10. Okay, this continues, and then it stops right here, but I have a closed circle up there, so it's still going. It stops here, but again, I have a closed circle at 2, and then it keeps going until it gets all the way to 10. If you look at this, it starts down here at negative 29. It goes up. This one's still going up, so up. It stops here. But then this piece picks up, it's still going up. So it goes all the way to positive 10. All right, as far as increasing and decreasing, from left to right, I already know that it starts at negative 10. So at negative 10, it's going up till we get here, and it stops going up at an x value of negative 2. So stops going up at an x value of negative 2. So we're increasing from an x value of negative 10 to an x value of negative 2. Then from there, it starts going down until we get to an x value of 0. So I am decreasing from negative 2 all the way to 0. Then my graph, starting at 0, starts going up again until we get to an x value of 2. So from 0 to 2, we are increasing. And then that piece stops, but this piece picks up at 2, and then from there until we get to here, which is 10, it is increasing again. So from 2 to 10, we have another section of increasing. We always use parentheses when we're talking about increasing and decreasing. Okay, so we're taking a look now at another piecewise function. Okay, this one is linear. We have a power of 1, so this is a line. This one is also a line. This one has a power of 2, so that's quadratic. It's a U shape. And again, you can look up some parent functions to know if you're getting them right or not. All right, so let's do tables for all of these. So I'm going to start with the 2x plus 5. I'm going to look, I'm going from -6 all the way to -2. So -6, and since it's a line, I'm going to kind of count by 2's here. All right, now I know that at -6 we're included, and at -2 also included, so both of these will be closed circles. And if I fill in my table, that makes -7, -3, and 1. All right, for the second graph, we have 2x squared minus 7. And I'm going all the way from -2 up to 1. So -2, -1, 0, 1. At -2, no equal to. At 1, no equal to. So both of these are open. And my table filled in is 1, -5, -7, -5. For the third, we have -4 minus x. Again, that is linear. I'm supposed to start at 1 and end at 3. So 1, 2, 3. 1 is included, 3 is included. So we have closed circles on both of these. All right, my table filled in is -5, -6, -7. So let's graph these. So -6, -7, we have a closed circle. -4, -3, and -2, 1 is also closed. And then we connect those dots. Then we have open circle at -2, 1. That's overlapping, so I'm just going to kind of put an open circle around it. Another point at -1, -5, 0, -7, and 1, -5. But that is open as well. Draw that one in. And then we have our third graph, which has a closed circle at 1, -5. I'm just going to kind of put that in there. 2, -6, and then a closed circle at 3, -7. And then again, I'm ready to draw that in. So let's talk domain and range. So my domain, again, it's starting at the lowest value of x I have is -6. And it goes all the way up to -2. -2 is included. The second piece picks up at -2, where it's not included. Goes all the way to 1, where it's not included. But then 1 is included in the bottom piece all the way up to 3. So my domain is going to be -6 is included because there's an equal to bar right there with it. All the way up to 3, which is also included because there's an equal to bar. So my x's are going from -6 all the way to 3. For my range, again, since I know I don't have any breaks, I can look at my tables here. It looks like -7 is the lowest, but 1 happens to be the highest. Now at -7, I do have a closed circle. So I know this is a bracket. And then at 1, I'm open with this equation and closed at this one. So that is included. So all the way up to 1. So my y's are between 1 and -7. Again, you can look at that on here visually. -7 is the lowest. And I have y values all the way until I get to +1. Same thing here, -6 all the way to +3. So where we are increasing and decreasing. So if I start right there at -6, it's going up until it gets to -2. So I'm increasing from -6 to -2. Then my graph starts to decrease, starting at -2. We decrease until we get to 0. So from -2 to 0, we are decreasing. Starting at 0, we start increasing until we get to 1. So increasing from 0 to 1. And then from 1, we decrease until we get to 3. So 1 to 3. All right, and then here's our last example of piecewise functions. So we're going to start with the first one. This doesn't have a variable. That means it's constant. It's a flat line, okay? This has x to the first, so this will be a line that's slanted, and this will be a line that is also slanted. So we don't have any U-shapes. We have a flat line and two lines that are slanted in one way, shape, or form. So let's start with 3, and we're going to make ourselves a table. Now, this is telling us that it's flat from -4 all the way to -1. So -4, -2, -1. You can do that however you want to. You can graph all 4 of them if you want. So it doesn't matter what my x is. The y is always just 3. This is y equals 3. So when x is -4, y is 3. When x is -2, y is 3. When x is -1, y is 3. Now, when x is -4, I see right here there's no equal to, so this would be an open point. When x is -1, I have an equal to bar, so that will be a closed point. We'll move on to the next equation. We have -x going from 0 to 2. 0 is equal to, and 2 is equal to, so we will be closed and closed. And again, I could use my table on my calculator. I could just fill in. This is going to be 0, -1, -2. And then for my third graph, I have 3 minus x going from 2 all the way to 4. So 2, 3, 4, no equal to, no equal to. So both of these endpoints are open, and my table filled in is 1, 0, -1. So we're going to go ahead and plot these. So I have an open point at -4, 3. Then I have -2, 3, -1, 3 with a close point. So we really do have a flat graph. Okay, then we're going to pick up with our second one. We have a closed circle at 0, 0. And then we have a point at 1, -1, and then a closed circle at 2, -2. Draw that together. And then our third one, we have an open circle at 2, 1, 3, 0, and then open at 4, -1. So let's talk about our domain and our range. So for the domain, I see that I start at -4 and I go all the way to -1, but then the second piece doesn't pick up at -1. We start here, we end here, and then we jump to 0 and go to 2, and 2 is included, but then 2 is not included here, but it picks back up between the two pieces. So I have a little jump, so I have two little sections of my domain, and you can visually see that between here and here, I don't have any points plotted. So my domain starts at -4, and there is an open circle there, so I need a parenthesis, -4. And then it stops at -1. There is a closed circle there, so -1 with a bracket. And then I have another piece in my domain that starts here and then continues the rest of the way until here. So from 0 to 4. At 0, that's closed, so bracket 0, comma 4 is open circle right there, so not included. So if I wanted to write that as an inequality, I go from -4 to -1, and my y's go from 0 to 4. Okay? So now let's talk about the range. So from the range, it looks like if you want to look at it visually, the lowest you have in your range is -2. So I definitely know that there's a -2 is the lowest I go. Okay. And there's a closed circle there. So -2 all the way up until I get to right here, and then it stops and I don't have any points between here and here. So all the way to 1, that's an open circle, so parenthesis. And then the only other y value I have is right here, which is 3. So if I wrote this as an inequality, this will be my y is between -2 and 1, and this is literally just my y is 3. Okay, for increasing, well, I'm constant right here. It's not increasing or decreasing, so that's not increasing. And then my other two pieces are both going down. So starting at 0, this goes down until 2. And then starting at 2, it goes down until 4. So I have no intervals of increasing. As far as decreasing, it decreases from 0 to 2 and from 2 to 4. All right, so we are supposed to write a rule that describes this piecewise defined function. All right, so we have 3 pieces. All right, 3 pieces. All of them are lines. So I have one line here, one line here, one line here. So these are equations that literally are slanted. So these are linear. This one is constant. It's just y equals a number. So really the hardest ones are my first 2 pieces. So let's go with the first piece. All right, first things first. I could name these points. This point is -2, -10. This point is 1, -1. All right, I'll go ahead and name these points that way. We have the names on there. Now, I can find my slope by counting up and over if I want to. So this would be 2, 4, 6, 8, 9. I went up 9. And then I went over 1, 2, 3. So my slope is 3. Okay? And if you can see where you cross the y-axis, that's at -4. That would be your y-intercept is -4. So the equation is y equals, this is slope-intercept form, your slope times x, and then your y-intercept. So that equation is my first one. Okay, my second piece, I'm going to have to do a little more work. All right, first things first, I can count again. 2 up 4, so my slope is 4 over 1, 2, 3, 4. 4 over 4, so that's a slope of 1. But I can't tell where this is crossing the y-axis. Now, I can use the slope to find that. I know that my slope is 1, so I could literally drop down 1 and then run 1 this way. I wouldn't run this way because my line is literally coming down like this. Okay, so I know that that would be right there, so my y-intercept is 3. Now let's say that you don't know that, okay, or you're having a hard time because maybe it's numbered funny. Okay, then ignore that I wrote down the 3. I know that slope-intercept is y equals slope times x plus b. But I don't know what b is, so I could plug in for x and y, just pick a point on my line. So I already know this point right here. This point is 1, 4. So I'm going to put 4 in for y. I'm going to put 1 in for x. So that'd be 1 times 1. And then I solve for b. So I subtract 1. b is 3. I think it's easier to count down if you can count down and use your slope to find that out. But, you know, sometimes that's hard. So we have y is equal to your slope times x plus your y-intercept. All right, now I'm running out of room, so I'm going to erase part of this. All right, so for my third piece, my third piece is literally flat. It's just flat right there, and that's a y value of 8. So the equation would be y equals 8. So I have 3 pieces. I have 3x minus 4. That was my first piece. I have x plus 3. That's my second piece. And I have 8. Put your little brace on the outside, comma, comma, comma. Sometimes you'll see an if. So we'll put an if out here. And then you have to state your domains, like from where to where. So let me erase the busyness. All right, so I know that this piece goes from -2 all the way to +1. So I know that x is between -2 and +1. Now, if you look at where x is -2, there's a closed circle, so you need an equal to bar with the -2, but the other end has an open circle, so we don't need the equal to. My next piece, which is this piece right here, the green piece, I think, you know, and then we'll do the purple piece. So that starts here at +1 and goes all the way to 5. So my x's are between 1 and 5. So I look and I see that I have a closed circle at 1, so I put the equal to bar. And at 5, you really have to pay attention. It's green. It's a green whole circle right there. So we're going to put the equal to there. And then I know that from here, 5 to 8 is where I am constant. So x is between 5 and 8. I have an equal to bar right here at the 8 because it's a closed circle. But if you're equal to 5 here, you can't be equal to 5 at the bottom one. So if I have an equal to with this 5, then when this picks up, you can't have an equal to. And there's your equation for those. All right, so just a little bit more practice with the equations. So I see that I have 3 pieces again. I have 1, 2, 3. So I'm going to start with that most left piece. We always go left to right, so the left piece. This is counting by 2's, so make sure you pay attention to that. It's flat. So my first piece is y equals whatever that x value, y value is, which is 7. So y equals 7. Okay, my next piece is this middle piece here that goes from here to here. All right. So I'm going to see if I can find my slope. Looks like this is 1, 2, 3, 4, 5. So 5 down, that'd be negative, and over 2, 4, 5. So that means my slope is -1, and I'm crossing at 5, so my b is 5. So my equation would be y equals -x plus 5. My third equation, which is right here, that one is going to go from 4 to 6. My slope, if I count up, that's halfway through. So 1, 2, 3, up 4, and then over 2, up 4 over 2. So positive 4 over 2. My slope is 2. Now, you can, again, take that where you're at and count down and go down 2 over 1, okay, to the left. You got to go backwards because it's going this way. So if you went down 2 and left, down 2 and left, you would cross right there at, oh, I didn't count right. So I'm going to take and go down to right 1. There we go. Down 2, right 1, down 2, right 1, down 2, right 1. It will be here. If you don't want to do that, then you're going to have to pick a point that's on that line and plug it in and solve for b, just like we did in the previous example. So my b in this case is negative 3, so the equation is y equals 2x minus 3. All right, so I'm going to write my function, f of x equals, so we have 7, negative x plus 5, 2x minus 3. Put your brace, comma, 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 if. And then state what x values. So this one goes from negative 5 to positive 2. All right, we have closed circle, so equal to, equal to. All right, the middle piece is going to go from negative 2 to 3. So negative 2 to 3. And we have this dot right here. Now, I can't tell from looking at this which one it went with. So I put it with the first one, okay, the equal to circle. But if we're equal to, like in the top piece, we can't be equal to this negative 2 here. So I have to leave this one open. And then I have a closed circle here at negative 3. And then the bottom piece is going to go from 4 to 6. Now we have an open circle at 4, closed circle at 6. I'm going to have to erase this so I have some space to go through part B. So again, we have 3 pieces. All right, let's start with the piece on the left. So we have y equals, my slope is down 1, right 1. Notice we're counting by ones here. So my slope is negative 1. So I have negative 1x. And then I could just follow this down 1, right 1, down 1, right 1. So it crosses at 0, so this is just y equals negative x. All right, we're flat right here at 1 in the middle. So this is just y equals 1. And then my third piece is y equals, let's get our slope. We're going up 1, up 2, up 3, up 4, over 1. So 4 over 1, which is just 4x. And then if I extended this and went down 1, left 1, it would cross at negative 2. All right, so when I put my function down here, I have f of x equals, so we have negative x, 1, 4x minus 2, with my bracket, comma, 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 if. So now we're stating the intervals. So the first piece is from negative 3 to negative 2. So x is between negative 3 and negative 2. There is a closed circle and then an open circle at negative 2. My second piece goes from negative 2 all the way to, oops, a little bit farther over, 1. So x is between -2 and 1. So I have a closed circle at -2, open circle at 1. And then we have this equation when your x is between 1 and 2, closed circle at 1, open a closed circle also at 2. All right, so can we rewrite the function f of x equals 6x plus 18, absolute value there, as a piecewise defined function? Well, we have y equals a times the absolute value of x minus h plus k. So I'm going to look, and I see inside here that we have a common factor of 6. So let's take, I don't have an a out here right now, but let's take and factor out a 6. So 6x divided by 6 is x, and 18 divided by 6 is 3. And then I don't have anything being added back here right now. So now I look, and I'm taking the absolute value of two things that are being multiplied. So I can take the absolute value of 6 and pull that out front. The absolute value of 6 is 6. And then all that's left inside here is x plus 3. And now I've simplified that, and I have nothing back here. Now, I wouldn't normally say write the plus 0, but for a visual, we're going to write it. So the vertex, we know, is going to be the opposite of this number, comma, the number here at the back, so 0. That is what this graph is over here that I have already graphed, is the graph of the absolute value of 6x plus 18. Now, I could graph 6 times the absolute value of x plus 3. I still get this graph. All right, it's the same thing. Notice your vertex is at -3, 0. So we're going to consider that the break where the piece is at. So we have the left piece and we have the right piece. So I'm going to take and do f of x is equal to, and I have two pieces, okay? One is going to be this left piece. That has a negative slope. All you have to do is change the sign of both of the things that are in here. So we're going to make that a -6x. Let me move that up just a little bit. -6x and a -18. And then you're going to do one that is exactly what is inside there. So 6x plus 18. Put your brace, comma, comma. So the left piece is this is just going to continue going this direction. All right, it never stops. So that means that it's from -infinity until we get to -3. So in other words, it's all the x's that are less than -3. Now I could say equal to on this one and then not put the equal to on the other because we're going to pick up at 3. It's, really your preference. Then we start at -3 and all the way to the right. This is just going to continue to the right. So these are all the x values that are greater than or equal to -3. So take a look at part A. I see that I have a common factor of -5. So I'm going to factor out a -5. So -5. -5x divided by -5 is x. -10 divided by -5 is +2. And then I can take the absolute value of each of these separately. So the absolute value of -5 is +5. And then I have x plus 2 left. Again, I don't have anything on the outside. So my vertex is at -2, because it's the opposite, comma, 0, because I have nothing back here. So let's break this up into pieces. We don't even need a graph to look at. We already know. We're going to change the sign of both of these and keep them the same. So I'm going to do -5x minus 10 first, and then I'm going to do 5x plus 10. If and if. All right, so The 5x minus 10 is actually going to be the left side of my graph. If you need to graph it and look at it, then do that. And we're stopping at -2. That's where it stops and moves up, all right, or down. That's where the break is at. So if I graph this, I know that these are all the values if x is less than -2, and these are going to be the values when x is greater than or equal to -2. All right, if I look at part B, I don't have anything to factor, but I can take the absolute value of the 1/2. So when I do take the absolute value of 1/2, that gives me 1/2. And we have a negative out front already, so that would be -1/2 absolute value of x plus 3. That means my vertex, I don't have a number being added or subtracted in here, so that would be 0, 3. Now we have a number out back there. So I have f of x equals 2 equations. All right. The first is going to be the -1/2 x plus 3. Not the negative, though. That's going to be on the second one. And then -1/2 x plus 3. Now, why did I not change the 3? Because all I changed was the value of what was in here. So I did the positive version of that, and I did the negative version of that. So positive version of that, negative. Because a negative times the -1/2 would give you a positive. That's why this one's positive. And then a positive times the negative would give you the negative. Comma, comma, if. So this would be when x is less than 0, and this would be when x is greater than or equal to 0. Okay, now let's talk about some step functions. All right, so we have the weight of items here. We've got some shipping costs for an online store. It tells you that the weight is your x and the shipping cost is your y. And then we are supposed to graph it, talk about the domain and range, and the minimums and maximums. We call this a step function because when we graph it, it's literally going to look like steps. So I know that if my weight is from 0 to 2, it's going to be a flat $5. So on my graph, I'm going to go from an x value of 0 to an x value of 2, and I'm going to graph it at 5. It's a flat line. So open circle at 0, closed circle at 2, draw the line. And again, I'm at 5 right there. So now I do the same thing for the next one. I'm going to go from 2 to 4 and graph a flat line at 8. So I'm going to go to 2, go to 4, and so 2 up to 8. We have an open circle when x is 2. All the way to 4, there's a closed circle when x is 4. And there's like your next step. All right. Then we do the 4 to 6 at 11. So up to 11, open circle, to 6 is closed. Up at 11. And then 6 to 8 will be at 14. So we have open circle at 6, closed circle at 8. And we have these steps. So what the domain means is, well, those are my x values. That represents the weight of my items shipped. So it can be all the way from 0 pounds all the way to 8 pounds. So my domain is 0, don't include 0 because you're not going to weigh something that doesn't have a weight, to 8 pounds. So this is the weight of items. All right, my range, well, I have jumps here. So my range is either $5, $8, $11, or $14. I don't have any prices in between that. Like if you look, there's a jump here, there's a jump here, there's a jump here. I don't have any y values located there. There are no points. So when you do your range, you have to use set notation and just list all of the options for that. And my range would represent the cost. So the minimum cost is $5. That's the least I'm going to pay. And the maximum cost is going to be $14. That's the most that I'm going to pay. All right, so just one more step function here. This time we're talking about fees for a parking lot. We're supposed to graph it and then do domain and range and maximum minimum. So I know that if I'm there 0 to 3 minutes, this is time, that it's going to cost me $10. So I'm going to go to an x value of 0. I'm going to go up to 10, put an open circle. All right, and then I'm going to go all the way to 3 minutes and put a closed circle and then connect those. So between those two times, it's going to cost me $10. Then it jumps up to 3 to 6 is 15. So open circle, closed circle, straight across. 6 to 9 is 20. Open circle, closed circle, go across. 9 to 12 is 25. So open circle, closed circle, go across. So my domain goes all the way from 0 all the way up to 12. So I have 0 to 12. Now, technically, I mean, I guess you could be parked for 0 amount of time, but then it wouldn't really cost you anything. So we will not include that. And that's just my hours in the parking lot. My range, again, is either 10, 15, 20, or 25. So I'll list that as a set. 10, 15, 20, or 25. And that represents the cost of parking. All right, the minimum is going to be $10. And the maximum is going to be 25. All right, and then we just have a summary here that talks about the different graphs and kind of gives just a little bit of information and some extra problems if you want to work through those. Hopefully this gives you some clarity about piecewise functions and helps you along the way.